let's take a look dividing by a monomial. What's a monomial again? That is one term. Okay. So when we divide by a monomial, we are going to divide each part of the numerator by that denominator. Okay? So if I just have one thing on the bottom, I'm going to take each part of the numerator and split it up like that. Does that make sense? Mm-hmm. So I'm going to take this into this. I have to be able to divide it into each part.
So do the second or do the first?
Wait, this one?
No, second one. Nope.
Wait, where?
20C to the fourth, the D to the second. You're right. No. Yes.
Oh, but it's the same thing as this.
Oh.
Sorry. Unless I copied it down wrong. I think I got everything right.
No one's
Yeah.
Oh, okay. All right. So when we divide, we're going to divide the coefficients, but then when we look at the exponents, we're going to subtract them. So 20 divided by 4, 5. 4 minus a power of 1, so c to the third. D squared over d is just d. And that's it, right? Because f, they're just basically going to cancel, right? Minus 16 divided by 4. 4, good. What happens with C and D? They just go bye-bye. And now f squared over f to the first is f plus. Good. So everything cancels, but I can't just leave it as nothing here. I need to include the plus 1.
So that's the final answer.
That's the final answer. That's it. Easy, right? Okay. Oh, okay, good. Because now we're going to do long division. Oh, come on, my favorite. Okay. We're going to learn 2 ways to divide a polynomial. We're going to do the long division, and then we're going to do synthetic division, which you're going to love. But sometimes we need to know how to do both, because next year in pre-calc, you're going to have review of these when you investigate polynomials further. And sometimes you have to use long division. But if we don't have to use long division, we'll use synthetic division, which is like very much a shortcut. Okay, we're going to review, because it's been a while maybe for some of us that we've done long division. So let's divide. Okay.
Can we just use a calculator?
We cannot use a calculator. Okay.
I mean, you can to check your answers.
Well, for this.
Is the test calculator
Okay. But the reason I want to review long division is I want to be able to write it out as like you have your remainder over what you're dividing by. Okay, so come on, we could do this. 4 goes into 7, 1. Right? The reason I'm doing this is because when we divide by polynomials, it's the exact same process. So we see how many times it goes in 1 time. Then we multiply 1 times 4, which is 4, right? Then I have to subtract, right? So we bring down the 8. 4 goes into 38, 9 times, right? Then we multiply, we get 36. What do we do next? Subtract, we get 2. Bring down that 9. 7 times, we get 28. Subtract. So this is our remainder. So if I want to write this as a fraction, a mixed number,
197.
we're going to put 1 over 4.
I got 197.25.
0.25 is how you would write it as a decimal. The reason I wanted you to write it as a fraction is that's how we're going to divide using polynomials. Okay, so, all right, see how many times it goes in, multiply, and then subtract. Right? 1/4 is the same as the 0.25.
Oh, okay. What if the decimal is different?
No, it should be the same.
So the answer is 197 and 1/4.
Yep. Okay, so we're putting what we're dividing by on the outside, polynomial on the inside, leave some space because we're going to obviously write your answer here. Okay. Now, this is a little tricky when you first see it, but how many times does x go into x squared?
Twice.
X to the first power. Think about it this way. What times x will give us x squared? X. So we always want to make sure whatever we have here when we multiply, it should be identical to what we have above. Okay? All right, when we did long division, what did we do next? We multiplied. Okay, so I'm going to take x times x is x squared. X times a minus 3 is minus 3x. Let me pause there. Just make sure did we understand that process?
No.
Not at all.
So we need
Zero.
to do it to
Okay.
both.
Like,
Do you remember?
3 times x.
Do you remember when we had to multiply here?
How did the
Right.
3
You
get
need
in
to
there?
multiply
Oh,
both.
oh wait. Oh,
Why is
oh
it-
yeah.
why is it-
Why are you
I
only
see.
looking at the x to get x squared?
So,
Like,
whatever is here, you have to multiply this to both parts. You're distributing.
well, yeah, but like, why to get that x in the first place?
But then you're only looking at the x.
You're only looking at the first one. Why, when we divided, did we just look at the 7 first?
No, it didn't.
Right? I didn't, but the same thing here. X, I only looked at x goes into x squared.
Yeah, why aren't you looking at negative 3 goes into like it doesn't, but like
We don't need that part because to get that first term to be identical, I don't care about the minus 3. Right? I want just these two I'm concerned about. Okay. Well, when we did the long division with the numbers, what was the next thing we had to do? We had to subtract.
How do you get the 3x?
Addition.
Wait, where did they get that?
Wait.
Okay, guys, it's not
Oh.
it's multiply. Okay.
But then why is there an x on top and no 3 on top? I understand. No,
because
Okay.
x times x is x squared.
you multiply the x to that. Obviously.
Okay, I have a little silly.
Is there an easier way to do these?
No.
There's no way.
Is there like a trick?
No. Well, yeah, there is. That's a different method, but not with long division, no. Okay, next. What we want to do is we want to subtract these. But I know it's a little silly rhyme, but what I like to do is draw the line, change the signs, and then combine. So take a look. We're going to draw the line. And we're going to change the signs on the bottom row. So minus, plus, and combine. What happens with the x squareds? 0. That's what we wanted.
So it's 10x.
7x plus 3x, we get.
So you bring down the 30?
Because, okay, remember when we did long division, we subtracted?
So you have to
Instead,
change those lines.
so 7x minus negative 3x is 10x. But I like to do this, just change the signs and combine. I see less mistakes when students do that. Okay, we're not done. Next, we need to bring down, remember when we did long division, once we divided that first part, we need to bring down the minus 30. Then we do it again. Okay.
Doesn't x minus 3 go into like
Yeah.
perfect?
10 times.
10 times. What would I need to put here to multiply to x to get 10x? A plus
10x squared. No,
10.
it's that way.
Okay.
Oh, that's right.
Again,
It works for both.
so now we're going to take 10 and we're going to distribute it to both parts. So plus 10 times an x is a plus 10x. Plus 10 times a minus 3 is a minus 30. Now we're going to do the little draw the line. So draw the line, change the signs on the bottom.
0.
0.
I don't think she does.
So what's our answer?
X plus 10.
X plus 10. Did we have a remainder?
Mm-mm.
No, so we didn't have to worry about it in this case. Okay. This x minus 1 to the negative 1 would just mean we're putting x plus 1 in the denominator, or x minus 1 in the denominator, right? So basically this would be x squared minus 13x plus 11, right? And we would have x minus 1 to the negative 1, we would put that in the denominator. It's just another way of saying divide. Okay, let's try this one. Okay. This one's not going to come out evenly, so we're going to have a little bit of difference in the answer.
You start with x at the top again?
Yeah. You were going to say that?
I was.
X goes into x squared, x times. Okay, now what we're going to do? Distribute to x minus 1. So that's going to become x squared minus 1x. Okay, now my draw the line, change the sign, and combine. Again, if these don't cancel, then we did something wrong. So that first term should always cancel. Negative 13x plus x.
Bring down that 11.
Bring down the 11. At least the nice thing with long division, it's like the same process over and over again. When you first see it, it's a little confusing, but it's like the same thing every time.
11.
Negative 12.
Oh.
Because remember what I just said. When I multiply this, I should get the exact same term. So now we're going to multiply negative 12 times x is negative 12x. What happens when I multiply?
Plus 12.
Okay.
Negative 1.
Now we're going to draw the line, change the signs, combine. Okay, so the 12x's, the minus 12x and the plus 12x will cancel, but 11 minus 12 gives us, okay, so
Oh, so that's it.
my answer is going to be x minus 12 minus 1 over, what did we divide by? X minus 1. So when we have a remainder, we're simply going to put the remainder on the top over what we were dividing by. Remember back when we did this one? What did I put the remainder over? What we were dividing by.
Yeah.
Same idea, okay?
So where do you get plus x on the like with no down? Yeah.
No. So it's x squared minus 1x, and then when we drew the line, changed the sign, combine, I made it a plus.
Oh, because I was getting confused because I saw the negative 12 and that's what
Oh, got it. Okay, let's try this one. X plus 1 into 2x cubed plus 3x squared. Okay, so this one's a little bit bigger of a polynomial and it has a coefficient, but that's okay. We can handle coefficients. Okay, x goes into 2x cubed.
2x squared. Good. 2x squared.
2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x squared. 2x s Why do we have the 2? Because we have to compensate for that 2 there. 2x squared times x is 2x cubed plus 1 times 2x squared,
Oh.
2x squared. Next, we're going to draw the line, change the signs, combine. Obviously, the first ones we want to cancel. What's 3x squared minus 2x squared? Just 1x squared.
Bring down the.
Bring down the minus 4x. Okay.
And then on top it would be plus 1.
Maybe not.
X.
Yeah.
Plus 1x plus x. Because, again, you need to be able to cancel this, so you need to get the same thing. So x squared plus x. Draw the line, change the signs, and combine. What's this going to end up giving us?
4 negative 5.
Good, negative 5x plus 15. Almost done. This is the last step.
Negative 5.
Good, negative 5. So negative 5x minus 5. Change those signs and combine. So what do we get for our remainder this time? 20. So up here, I'm just going to write the answer up here this time. Plus, I need to include a plus or a minus. So the last problem had a minus 1 as the remainder. This one has a plus 20.
X. Plus 1.
Good. Owen?
Why do you make the 5 plus?
Because it's 15 minus negative 5. So it's really
Oh, yeah,
15
right.
plus 5. You're really subtracting. So
Harder than this.
that's as hard as the long division is.
Okay.
Synthetic division
Okay.
as a piece of cake after this. Okay, so this is just summarizing. So when I divided, right, you have your divisor, your quotient, and your dividend. How do you write it? You end up with your quotient, right? So this is your quotient, and then that's the remainder, okay? All right, synthetic division. We're not done. We're not done. Okay. So, first of all, this is a mistake here. First thing, what we want to do is we're going to write the coefficients. I kind of have it written out step by step, so we're not going to write the coefficients of the dividend. That means the top part. 3, 5, negative 1, 4. Do you see where we get those numbers? They're all here. Next, we want to write the constant outside the box. So I kind of make this big box, L-shaped kind of thing. And we want to take whatever we're dividing by, set it equal to 0, and that's what we put outside the box, okay? So again, we're taking all the coefficients, putting them here, and then whatever is here, plus 1, we're going to have a negative 1. Okay, we're going to go to the next page and I'll walk you through the process. Okay. Actually, it kind of ends here. So the first step actually was just setting it up, and you're always just going to bring the first coefficient down. So that 3 just goes down there. Okay, now we're going to multiply. So you're going to multiply 3 times the negative 1, and we're going to put negative 3 right here. So it's going to be a combination of multiplying and then combining. 5 and negative 3. Because 3 times negative 1. So you're going to multiply these to what's on the outside, and then you're going to add straight down. So we're always going to add when we bring stuff down. The first one, there's nothing to add to, so that's why we just bring down the number. Now, 5 and negative 3 give us 2. Now I want to do 2 times negative 1. That's negative 2. Add vertically, so that's going to give us,
Wait, what did we multiply? To get the -2, what did we what did you do?
2 times negative 1.
Oh, okay.
So we always like multiply these and then add straight down. Okay? Now -3 times -1, 3. Add, we get 7. Now we're going to rewrite it. Do you remember what we started with? We started with a 3x cubed. So if we're dividing by a power of 1, what do you think the first term's going to be?
1.
Okay, writing the answer. The coefficients here, these numbers here, are the coefficients of my answer. Okay? The power of the first term is 1 less than the degree. Yeah, so notice we started with an x cubed. So it's going to be 3x squared. Okay, this is our next coefficient, plus 2x. This is our next coefficient, which is really not minus 3x, that would be x to the 0 power, that's our constant. This last number, that's the remainder. So that's going to be plus 7 over, what were we originally dividing by?
1.
X plus 1. And that is the answer.
2x and then a constant
Yep.
remainder.
Okay, so let's try our own here. Okay, so if it's a minus 1, then we want to divide by a equal to 1. Okay, my coefficient of a cubed is 1. A squared is 1. -4. And 12. Okay, so I'll walk you through this one and then, so bring down that 1. 1 times 1, we get 1. And then bring down, okay, so now we add these and we get 2. 2 times 1, 2. Add, we get -2. -2 times 1, 2, which means our remainder is 10. Okay, now we want to rewrite it. Now, since we started with a instead of an x, we want to write it with a to what power? A squared, good, and it's just 1 as the coefficient. Plus 2a minus 2, and 10 is the remainder, so we're going to do plus,
Plus 10 over a minus 1.
good. A lot easier than that long division. What do you mean? We're just adding?
No, and like how you get your final answer.
Yeah. You just start, see how you started with a cubed? This is just going to be 1 less, a squared. Okay. This one starts with a b to the 4th, so I should start, my answer is going to be starting with a b to the 3rd. Okay, you're right with the 1. The 1 is the coefficient. Now, I have a b to the 4th, a minus 2b to the 3rd. What are we missing? We don't have a b to the 2nd. So, I don't want to skip over it, okay? So we need to put 0 as a placeholder. So whenever we're missing a term, if that makes sense, right? It goes 4, 3, no 2, then there's a 1, right? So I need to put a 0 to hold a space for that variable. Then I have a 1, and then I have a -8. You want to give it a try? Did we do it already?
No.
Oh,
I'm just lost.
really? I'm sorry. Well, we got bonus today. Okay, bring down the 1, then what? Okay, so we get 2. We get 0. That's okay. That's fine.
And then 0 plus 0.
So we're going to have 0 times 2 is 0. 0 plus 0, 0. Lots of zeros in this one. 0 times 2,
Is 0.
0.
And then 1.
When we get 1, so finally we got rid of all those zeros. And then 1 times 2,
2.
and then add straight down.
-6.
Okay, so this is my remainder. Now, if I started with a b to the 4th, this would be b to the 3rd, this would be b squared, this would be b to the 1st, but I don't have any of those terms, do I?
No.
So I'm just going to write b cubed plus 1 minus 6 over
B minus 2.
b minus 2.
Just like when there's zeros, we just bump them.
Exactly. So if they're zeros, we just don't have any of those terms. Okay? Last page. Okay. Real quickly. Sometimes I want you to do long division, sometimes I have you do synthetic. Otherwise, I don't care. You pick which way you want to do it. But if there's a 2, remember all the ones that I divided by didn't have a coefficient here? You can do it by long division or synthetic division. Now, I haven't done one of these where we're missing a term. What are we? It goes from x to the 4th to x squared. So I'm going to put a plus 0x cubed minus 4x squared plus x plus 4. Now I'm just going to show the setup because we're running short on time. If we're going to try this by synthetic division, we need to divide everything by 2. Because I need to make this to divide by an x plus a half. So if I'm dividing by x plus a half, what am I going to put on the outside? Negative 1/2. And now I'm going to put all of these divided by 2. So I'm going to have 4. Don't forget, I'm missing the x cubed. So I'm going to just put a 0. Negative 4 over 2. Negative 2. Here, this becomes a half and a 4. Now, the reason I like...
Should be 2.
Oh, thank you. The reason I want to show you the 2 different setups, one, you end up with a whole bunch of fractions to deal with. The other one, you don't. But you should get the same answer either way. So we'll do the synthetic. Let's bring down the 4. 4 times negative a half?
Negative 2.
Negative 2. 0 plus negative 2. Negative 2. Negative 2 times negative a half? 1. Negative 2 plus 1. Negative 1 times negative a half? Oh, yeah. What do we get? 1/2 plus 1/2?
1/4.
That's if you multiply. And then 1 times negative a half.
How'd you make the half a negative?
Because remember, we take whatever we're dividing by and setting it equal to 0. So I'm dividing. And then this ends up with 3 over 2. So my answer should be 4x cubed minus 2x squared. Or sorry, cubed. No, squared. I'm sorry. Minus 1x plus 1 plus 3/2 over x plus a half. Okay, now the only thing is I would multiply the top and the bottom of this by 2, and that will make it, it'll make it what? Plus 3 over 2x plus 1, because we really want to have it written by what it was dividing by. If you do the long division, we didn't have time, but if you did the long division, you'll get the exact same answer, okay?
I need what you started with for the